So if we're asked to find the border and the cost of a border, we need to know the perimeter. So that's dealing with the outer edges only of this shape. So again, we're not going to use the formula sheet for perimeters. We're going to use our mind and think about which sides apply. The challenges are, we don't know these edges, and I think we can assume that these are equal. So let's first use symmetry and some basic observations to fill in the sides we do know. So if 12 goes all the way across, that means each of these would be half, so that's 6. And you can see this is not drawn to scale. It's clearly not 6 if that vertical part is also 6, but that's okay. Always trust the label, not the picture. Go with what the numbers are. So we could recognize the Pythagorean theorem at work in this right triangle here. We could solve for the hypotenuse. We could figure out x squared by taking 6 squared plus 6 squared. So x would be the square root of 36 plus 36, or the square root of 72. So x is approximately 8.5, and it looks like these are measured in meters, given by the question. So now we know 8.5 and 8.5. Next, we're going to need to know the rounded part at the end, and we'll assume that's a semicircle, because we would have no other way right now anyway of figuring out less of an arc if it wasn't a full half. So the semicircle portion of it, semicircle, is pi times diameter divided by 2 for half of a circle. So we could get pi times 12 divided by 2, or just do pi times 6, same thing. And we get about 18.8. So now we would have the border, or the perimeter. We'll use the word border because that was in the context of this question. But the border would be 85, 2 of them, so 8.5 I mean. 2 8.5s, we've got 2 12s, and the arc at the end we figured out was 18.8. So just close that off. So we can get the total number of meters going around this patio. So we get about 59.8 meters. Now that's not the full question yet. Now that we have the distance around it, it wants us to calculate the cost, including 13% tax of the border. And so the border is $3 per meter. So we would get the cost by taking the number of meters and multiplying it by $3. Because it's $3 per meter. And this is before tax. Before tax. So if we wanted to know the after tax, a few ways we can do that. We could use a proportion method where we sort of said after tax, so 100% goes, that's our original amount. So the original amounts go on the bottom. And then after tax, it would be 113%. So that's what we want to figure out. And we could cross multiply. And we could multiply these across from each other. So multiply and divide by the one across from the x. And we would get x equals 113 times 179.4 divided by 100. And we realize this is $202.72. Another method of adding tax is just to recognize that instead of $1 every every dollar is going to go up by 13 more cents because the government says you pay us an extra 13 cents for every dollar it costs. So we could just take the price and multiply it by $1.13 to figure out the new amount, and you'd get the same thing. Essentially, you end up doing that anyway because you'll see that 113 over 100, that's a 1.13. So that kind of hiding in there, really what you're doing is multiplying $179.40 by 1.13. So they accomplish the same thing. And if a question is given in a sentence, you probably want to answer it in a sentence. So you could say the cost of the stone border is $202.72. And you would need to do these kind of calculations if you were ever planning a landscape project, because you don't want to go to Home Depot and buy too little stone or not have enough money for the cost of your garden. Okay, I believe there's a second component to that question. Maybe not, just the perimeters involved there. Nothing to do with area. So that is it for that example. So hopefully you guys are equipped to recognize where the Pythagorean theorem is involved and not be afraid of the extra calculation steps to use it and get the missing measurements that you need to find area or perimeter given the context of the problem.